Good morning. I'm here to walk you briefly through the double mass problem to get you started on your investigation today. We will review the free body diagrams you drew on our remote day and derive an expression for acceleration in a zero friction environment. I'm estimating it will take you about 20 minutes to collect your data with your partner, and the remainder of your class will be spent working towards the completion of your investigating and analyzing formative. So briefly, let's revisit Wednesday. I asked you to draw free body diagrams for mass 1 and mass 2 in this double mass problem setup. Here are some sample student answers, and what I appreciated about these sketches were that they were similar. You did great, and you recognized the direction of the net force for each object. For example, for the mass of the first object, this person recognized that vertically there are two forces that are equal in magnitude and opposite in direction. They're probably balanced. There will be a zero net force in the vertical direction. However, you notice that there's a horizontal force pulling this object to the right, so we can deduce or we can imagine that there's a net force in the horizontal direction. Similar drawings for mass 1. Let's look at the mass of the second object. Here, this person recognized, again, there are two forces acting on this object vertically, and none acting to the left or the right. I found it interesting. Some of you labeled it air resistance, which is great. It's probably true. And remember, there's also the force of the tension of the string holding it upward. For this investigation, we're assuming zero friction. So although there probably is air resistance, we are not accounting for it today. And although there probably is a frictional force acting on the surface of the object, we're also not including that. So to conclude, the free body diagram for mass 1 is as follows. We have the force of gravity acting downward, the force of the table holding it up, we call that the normal force, and this force, I'm calling it tension, pulling this object to the right. Another way of thinking about this is that the acceleration in the y direction is zero. The object's not flying off the table or falling downward. It's balanced in the y direction. However, the acceleration in the x direction is not equal to zero. In other words, this object is accelerating to the right. For the second object, we can see that there is no acceleration horizontally or in the x direction, so ax is equal to 0. However, in the vertical direction, or the acceleration in the y direction, we have a non-zero acceleration. In other words, the force of gravity is probably going to be pulling this object down, even though there's a little bit of resistance from the tension of the string. So the mass, the first object, m1, this accelerates in the horizontal direction, whereas for the second object, m2, it accelerates in the vertical direction. One more thing to note, Fg, what is this? This is the weight of the object, and you already have derived the value for weight. You know that weight is equal to the mass of the object times the acceleration due to gravity. So another way of writing Fg is mass 2 times gravity. All right, this concludes our first video. Let's pause. You can take a moment to obtain all of the materials that you will be using for the investigation, bring it back to your table, and we'll meet back in a few moments and I'll share with you the derivation. See you soon.